Good day everyone, welcome back to this channel. From our YouTube intro, we said we will offer free online courses to all students globally, provided you understand English. So we will be starting that mission by introducing motion challenge to everyone. I would love to teach that topic, motion in physics, to everyone because its questions are one of the most repeated questions in external exams having physics questions like UTME, AP, NEET, MCAT and so on like that. Today we'll start with motion in one dimension. I will introduce you to the basic concepts of motion, then we will solve questions on motion in one dimension ranging from the basics to the advanced level. So in our next video I will talk about motion in two dimensions and we will solve questions pertaining to two-dimensional motion. So I will advise you to subscribe to this channel and turn on your notification so as to be informed when the video drops. Guess what? The subscription is free. Just click on the button and that's all. Now to the main topic. Life is motion. You walking, running, swimming, dancing, eating, or doing anything that involves you moving your body parts are all examples of motion. Your heart pumping blood is also an example of motion. All these are enough reasons to prove that life itself is motion. Yes, life is motion. And like I said earlier, I said I'm going to put you through some basic concepts of motion. So I would like to start this video by telling you what kinematics is. Kinematics is defined as the study of motion without considering its causes. And of course in this video I'm going to talk only on kinematics in one dimension. In my next video I will talk about kinematics in two dimensions. So I would advise you to like and subscribe and share to your friends so that they can also benefit from this channel. So what is motion in one dimension? Motion in one dimension is motion along a straight line, and this kind of motion, of course like any other motion, involves displacement, velocity and acceleration. So I will also explain that too. The displacement delta x of an object is defined as its change in position and is given by delta x is equal to xf minus xi, where the xf means the final position of the object and xi means the initial position of the object. The SI unit for displacement is meter. And I want you guys to know that displacement is a vector quantity. A vector quantity is a quantity that has both magnitude and direction, while a scalar quantity has magnitude but no direction. Because displacement has both magnitude and direction, it is a vector quantity. The mnemonics not to make this complicated and avoid you mixing it up is S1 V2. In the alphabetical order, S comes before V, so definitely S will carry 1 while V will carry 2. The 1 and 2 means 1 means only one magnitude, while 2 means both magnitude and direction. S means scalar quantity, while V means vector quantity. Now to velocity. Before defining what average velocity is, I would love to explain what average speed means, because people mix up average speed with average velocity, which is wrong. Average speed of an object over a given time is the length of the path it travels divided by the total time elapsed. It is distance traveled over elapsed time. Like I said earlier, displacement is the change in position of an object. So displacement is different from distance. Distance is just the length of the path traveled by the object, while displacement is the change in position of the object. The SI unit for average velocity is meter per second. Moving to average velocity during a time interval delta t is the displacement delta x divided by the time interval delta t. So average velocity is the displacement over time interval, not the distance. It is displacement over time interval. The SI unit for average velocity is also meter per second. Unlike average speed, average velocity is a vector quantity having both magnitude and direction. Average speed is a scalar quantity, it has only magnitude and no direction. Now, the instantaneous velocity v is the limit of the average velocity as the time interval delta t becomes infinitesimally small. That is, it is the average velocity of an object as the time approaches 0. The SI unit for instantaneous velocity is also meter per second. It's also meter per second. Acceleration. The average acceleration of an object is the change in velocity of the object in a time interval. That is, the formula is change in velocity over change in time. The SI unit for average acceleration is meter per second square. We have both positive acceleration and negative acceleration, but I want you to note that deceleration is not negative acceleration. As a matter of fact, negative acceleration can also mean that the object is speeding up. When the object's velocity and acceleration are in the same direction, the speed of the object increases with time. That is, if the object's velocity is in the positive direction of x-axis or y-axis, and also the acceleration is in the positive direction of the x-axis and y-axis, the speed of the object increases with time. Also, if the object's velocity is in the negative direction of x-axis or y-axis, and acceleration is also in the negative direction of y-axis, or when the object's velocity is in the negative direction of the x-axis or y-axis, and the acceleration is also in the negative direction of the x-axis or y-axis, the speed of the object will increase with time. When the object's velocity and acceleration are in the opposite direction, which means if the object's velocity is in the positive direction and the acceleration of the object is in the negative direction, the speed of the object will decrease with time. So, negative acceleration can speed up an object. Deceleration means reduction in speed. Deceleration is not negative acceleration. Deceleration means reduction in speed, is slowing down. So don't confuse it with negative acceleration, which can speed up objects. Instantaneous acceleration A is the limit of the average acceleration at the time interval becomes infinitesimally small. That is, it is the average acceleration of the object as the time approaches zero. The SI unit for instantaneous acceleration is also meter per second square. When an object moves with constant acceleration, that is, its velocity is not changing and the acceleration is constant, the instantaneous acceleration at any point in the time interval is equal to the value of the average acceleration over the entire time interval. So now we'll be solving questions pertaining to one-dimensional motion. So this is the list of formulas under constant acceleration in motion in one dimension in physics. The first one is for displacement, second one velocity, the third one is acceleration, and these last four formulas are what we call the equation of motion, where x and s are displacements, v is the average velocity, a is the acceleration, t is the time taken, u is the initial velocity, and v is the final velocity. So we'll be using this formula to solve our questions. This is the problem solving strategy that we will be following. Number one, list out the given in the question. The second step, take a look at the list of formulas, and the third step, solve the question. So we'll be making use of this strategy throughout this video. Question number one, a jogger runs down a straight stretch of a road with an average velocity of 4 meters per second for 2 minutes. What is his final position, taking his initial position to be 0? Okay, this is a little bit cheap. In this question, we are given the velocity to be 4 meters per second, the time to be 2 minutes. We are going to convert it to seconds because the SI unit for time in physics is seconds. So 2 minutes to seconds will be 2 times 60 seconds. Since 1 minute is 60 seconds, then definitely 2 minutes will be 2 times 60 seconds to give us 120 seconds. So we are asked to find the final position of the jogger when its initial position is 0. From the list of formulas I gave earlier, only the second formula contains velocity, time, and displacement only. So definitely we'll be using the second formula. V, the average velocity, is equal to displacement over time interval. So V is equal to 4. 4 is equal to the final position minus 0, the initial position, all divided by 120 seconds. So you're not going to cross multiply. Your final position is not going to be 4 times 120, which equals to 480 meters. That's very simple. 480 meters. Moving on to the next question. The second question states an airplane lands with an initial velocity of 70 meters per second and then decelerates at 1.5 meters per second square for 40 seconds. What is the final velocity? Following the strategies I gave earlier, the first step is to list what you were given. So we are given u, which is the initial velocity, to be 70 meters per second. A, the acceleration to be deceleration to be minus 1.5 meters per second square, and t to be 40 seconds. What is the final velocity? The second step of the strategy is to look at the list of formulas given and choose which has everything that was given. So looking at the list of formulas here, the first equation of motion, this is the best because it has final velocity, initial velocity, acceleration and time. Back to the solution. V is equal to u plus at. The v is the final velocity, u is 70 plus open bracket minus 1.5 the deceleration, close bracket 40 the time, then v is equal to 70 minus 60 is equal to 10 meters per second. Taking a good look at the question, the initial velocity given is 70 meters per second and the acceleration is minus 1.5, that's negative acceleration. So definitely we should be expecting a decrease in the speed from what I said earlier, since the acceleration and the velocity are in different direction. That is, the acceleration is in the negative direction and the initial velocity is in the positive direction. So that makes our answer correct, since the final velocity is 10 meters per second, which means a decrease in the speed. Yeah, to the third question. On dry concrete, a car can decelerate at a rate of 7 meters per second square, whereas on wet concrete it can decelerate at only 5 meters per second square. Find the distance speeds necessary to stop a car moving at 30 meters per second on dry concrete and on wet concrete. Okay, so we'll be following the problem solving strategy. Step 1 says list out the given. So I'm going to list for dry concrete and wet concrete. Starting with dry concrete, we are given the acceleration to be minus 7 meters per second square, the initial velocity to be 30 meters per second, and for wet concrete we are given the acceleration to be minus 5 meters per second square and u, which is the initial velocity, to be 30 meters per second. Step 2, take a good look at the list of formulas and choose the most appropriate. So here, this is the most appropriate as it has the final velocity, the initial velocity, acceleration and distance. So now let's solve. A says on dry concrete, so we'll be solving for dry concrete first. The dry concrete, so v square is equal to u square plus 2as. The v square is the final velocity, this is 0 since the car is going to stop. The initial velocity is 30 as given in the question, then plus 2 times the acceleration to be minus 7 times s, the distance. So doing the necessary, 30 square is equal to 900, then taking 900 to the other side it will become minus 900 is equal to minus 14s. Then our s, the displacement, is minus 900 divided by minus 14s to give us 64.28 meters. Moving to the second one, the B section on wet concrete. v squared is equal to u squared plus 2as. The v squared final velocity is 0, the initial velocity is 30, the acceleration is minus 5, and the displacement is s. So doing the necessary again, 30 squared will be 900, taking it to the opposite side, it will become minus 900 is equal to minus 10s. So our s will be minus 900 divided by minus 10 to give us 90 meters on wet concrete. Moving to the next question. Before moving to the next question, I would love to inform you that you can actually make use of the comment section to ask your question, and I will definitely answer you. The next question states, a race car starting from rest accelerates at a constant rate of 5 meters per second square. What is the velocity of the car after it has traveled 1 times 10 raised to power 2, that's 100 feet, and how much time has elapsed? From problem solving strategy, step 1, list out the given. So acceleration is equal to 5 meters per second square. The final velocity is not given. S is 100 feet, that's 30.5 meters converted to meters, since the SI unit of distance is meters in physics. Step 2 is taking a look at the list of formulas and choose the best. And from the list of formulas here, this is the best, the third equation of motion here. V squared is equal to u squared plus 2as. Since it has final velocity, initial velocity, the acceleration, and the displacement, the v squared is equal to 0 plus 2 times 5 times 30.5 meters. V squared is equal to 305. Then square root both sides to give you v, the final velocity. So our answer will be 17.46 meters per second square. I hope we are all getting this. If you have any question, once again, you can make use of the comment section. I will make sure I answer every single question. Now to the second question, how much time has elapsed? Taking a good look at the list of formulas, we will be using the first equation of motion, d, since it has the velocity, the final velocity, initial velocity, acceleration, and time. So v is equal to u plus at. V 40.46 from our A, from the A section. We've gotten the final velocity to be 17.46, so I'm going to use it in the second aspect. The v is 17.46 is equal to 0 plus 5t. Our time will be equal to 17.56 all divided by 5 is equal to 3.5 seconds. That's all. Moving to the next question. This question says, suppose a car merges into freeway traffic on a 20-meter long route. If its initial velocity is 10 meters per second and it accelerates at 2 meters per second square, how long does it take to travel the 20 meters up the ramp? From the step 1 of problem solving strategy, we list out the given. We are given s, the displacement to be 200 meters, the initial velocity to be 10 meters per second, the acceleration to be 2 meters per second square, while we are asked to find the time. Step 2, taking a good look at the list of formulas. The second equation of motion is the most appropriate, as it has the displacement, the initial velocity, the time, all at the same time. S is equal to ut plus half at square. Sorry guys, there's a mistake somewhere here. It is the second equation of motion is s is equal to ut plus 1 over 2 at square, not ut square. There's, oh wow, It is A, guys. A. Thank you. A stands for acceleration, not U. So I will be correcting that in the solution. S is equal to ut plus 1 over 280 square. 200 as the displacement is equal to 10t plus 1 over 2 times 2 the acceleration times t squared the time. So 200 will be equal to 10t plus t squared. Then rearranging this will give us t squared plus 10t minus 200 is equal to 0. Then looking for the factor of the equation, minus 10 and plus 20 is the most appropriate. And after solving, we got t plus 20 to be equal to 0, or t minus 10 is equal to 0. And obviously we got a negative value and a positive value. Time can never be negative, so the minus 20s is a red flag. So here our time is 10 seconds. So in my next video we'll be talking about motion in 2 dimensions. First, I'll be answering your questions from this comment section. Second, I'll be giving out questions to you guys, and thirdly, which is the last, we'll be talking about motion in 2 dimensions. I'm going to teach you everything you need to know about motion in 2 dimensions. So I will advise you to like, share and subscribe to this channel. Guess what? The subscription is free. Just click on the subscribe button, then that's all. Bye.